Hello students, welcome to Math 3680 Applied Statistics. This is the very first lesson of Module 1, so let's have a broad overview of the entire course before coming back to the course material for Week 1, which is Descriptive Statistics. First, the overview, and the overview begins with a question: what is statistics? One way to answer this question is to focus upon the concept of data. Roughly speaking, statistics is a science of data. That's the way most of the textbooks are written, and most of the elementary level textbooks are written, The science of collecting, organizing, summarizing, and analyzing data, according to Sullivan, or the science of collecting, describing, and interpreting data, according to Johnson and Kuby. Furthermore, depending upon what we do with the data, we can classify statistics further into descriptive statistics and inferential statistics. Descriptive statistics is about collecting, describing, and presenting data, and inferential statistics is something I'm going to explain later. For now, let's go over to an example of a descriptive statistics. Here we go. It's an example of graphical presentation of data. This is about teens using cell phones while driving, and that's why we have a picture of a car, and then we have all these percentages and bar graphs. There goes an example of descriptive statistics. Now, how about inferential statistics? That's a little bit deeper, and for that, we need another concept which is even more important than the data. Our textbook author, J. DeVore, is focusing upon the concept of uncertainty in describing what the statistics is. Why do we need all those data to begin with? What are we going to do with those? And how are we going to do those? How do we apply those? All those questions revolve around uncertainty. In fact, it's the uncertainty that makes statistics statistics. This is a description by our textbook author. Discipline of statistics teaches us how to make intelligent judgments and informed decisions in the presence of uncertainty. That's what statistics is all about. So we must study uncertainty, which we are going to do using the mathematical theory of probability in the first half of the course. And then we're going to study how to make intelligent judgment and informed decisions in the second half of the course. And that part is inferential statistics. Let's go back to that example here. Here is another pretty picture, and this is about what kind of traits employers are looking for from possible employees. And we have all these percentages, pie charts, and a picture of a paycheck. Everything here is descriptive. So where is inferential statistics? It's way down here. 1,043 hiring managers, margin of error plus or minus 3 percentage points. Margin of error, where is the error coming from? It's coming from the uncertainty. And we have a margin of error not exceeding those. That means we were able to control those uncertainty at least to a certain degree. And that kind of thing is inferential statistics. Of course, there is more to it, but that's a kind of inferential statistics that we are going to study. Alright, so much for the overview in 1000 level. Yes, we did talk a little bit about our textbook author's description of statistics, but everything we talked about so far is just 1000 level. In order to go a little bit deeper, we need some terminologies. So let's begin. The first term here is population. Everybody must remember that. The population is basically a big set that we were interested in. A well-defined collection of objects that we want to study. And the population tends to be humongous, so big that it's immeasurable, or so uncertain that it's unmeasurable. Therefore, it's impossible to study population directly most of the time. So how do we study it? By taking samples. What is a sample? It's a subset of population. Relatively small number of objects selected from the population. Now, if the sample is a good representative of the population, our inferential statistics is going to be reliable. If it is not, if it is biased, then we're going to be in trouble. So that leads to how to take the sample. The key is to do the random sampling. That works. And of course, there are some more wrinkles. How about other sampling methods? Mostly they're all bad, and sometimes we may have to use those, but they all have severe defects, so I don't think it's good use of class time to talk about these kind of sampling methods. Instead, let's focus upon random sampling. We have simple random sampling and multi-stage sampling. The simple random sampling is something that we're going to study for this course. We're taking the samples directly from the population. Taking sample is not too difficult. Getting the population in ready, get a list of everybody from the United States, that's the hard part. Once you're done with the list and ready to take the random sample of say 500 from there, the list is no longer correct. So in practice, simple random sampling is not really effective, but mathematically it's simpler, and the theory of simple random sampling is necessary understanding the multistage. Multi-stage random sampling has many different components, each of which is simple random sampling, and then they are weaved together through some high-level mathematics. And we need some stochastic process there, so it's not something we can cover in undergraduate level. In undergraduate level, in 3000 level, we're going to study only simple random sampling. Okay, so much for population and sample. Now, the next concept is variable. As for variable, please do not get confused with variables from algebra or calculus. Things like this. X is an independent variable, Y is dependent variable. None of those apply here. This is statistics, not algebra. In statistics, a variable is a characteristic that takes values, and the values can be either qualitative or quantitative. For example, if you're interested in students' majors here in UNT Dallas, student major programs, that's the variable. Okay? They are not numbers, the majors. And math major or IT major, and education major, health science major, those are qualitative values. And if you're interested in students' heights, for example, then those are quantitative. So variables can be either qualitative or quantitative. Here is further classification. We can have discrete or continuous variable. Height, that's continuous because it comes from measurement. And for example, number of children in household, that's come from counting, so that's discrete. 0, 1, 2, 3, 4, those kind of things. And did I say major programs? Those are nominal variables, just names. Ordinal variables, there should be some order to it. Not just dictionary order, but really natural order. For example, this course, Math 3680, has a prerequisite. That's Math 2424, Calculus 1. And that also has prerequisite. That goes back to Math 1600, Trigonometry, and that has prerequisite. And that goes back to Math 1100. So what do we have? We have an order. That kind of things are ordinal variables. Even though we have course number 3680 or 1100 or 2424, we don't do any computation in those, so they are not quantitative. Finally, let's talk about data. And data means values of the variables, and they can be either qualitative or quantitative. They can be classified like this. Parameter means data from population. Statistic means data from sample. It's easy to remember, P is P, S is S, and also please pay attention to the color coding. Parameter are typically represented in Greek letters, and statistics are Roman letters. And as for the examples, I'm sorry I cannot show you. We're going to be ready in several sessions later, I think. And when we come to that, I'll come back here and remind you. Oh, and I forgot one thing. We talked about parameter versus statistic. How about univariate versus multivariate? If the data is coming from one variable, that's univariate, and more than one variable, then multivariate. For example, if you're interested in students' height, okay, that's height alone, that's univariate. Height and weight, then that's bivariate. Height and weight and age and cholesterol level and whatnot, then that's multivariate. Now that we went through all those terminologies, we'll be able to get a course overview in a little bit more precise terms like this. What do you mean by descriptive statistics? From population, we get sample. From sample, we get data, sample statistics, and we do some analysis, some computation and presentation. Those kind of things are descriptive statistics. Inferential statistics, on the other hand, is backward. From sample, we get data, sample statistics, and we do some mathematics, and then we apply it back to the population, either through estimation, either through estimation or prediction or other kinds of means. Those are inferential statistics. And they can be all summarized like this. From population, we get sample, but the key theory is probability theory. That's the theoretical background of the randomness and all those kind of things. So, how do we understand the uncertainty? Through probability theory. That's something we are going to focus upon in the first half of the course. And in the second half of the course, we're going to study inferential statistics. From sample, we do some mathematics and apply it back to the population. That's inferential statistics. Of course, the probability theory and inferential statistics are closely related as well. And there goes the course overview. That concludes section 1 overview, and we're going to meet again in separate videos for the other sections.